everyone. My name is Inifon Ime Ekpo. Welcome to Matter Face in Iblings. In our previous video, we were discussing about differentiation, and when I was uploading the video, I said if you have any question that you can comment on it. I was receiving 2 inbox questions from 2 different people. I don't know if they are brothers because the question looked alike. And the question was so shocking. Like when I see the function, I was like, whoa! Is this one actually going to be differentiable? But when I receive the question again, like I sit down, I look at the question again, I discover that we can differentiate the function. So you out there that is watching this video, please listen very well and follow the solution. Okay, fine, this is what we asked. I was asked to differentiate. I was asked to differentiate this function. This is how the question was written. Differentiate this function x raised to the power of x squared. X raised to the power of x squared. And when you have a function like this, the first thing you have to do, because you are asked to find the y, the x of this function, you said that let your y be equal to what? X raised to the power of what? X squared. And looking at this power that is up to 2, you have to apply the natural logarithm to what? To both sides. And if you apply the natural logarithm, apply the what? The natural logarithm to both sides, you have what? You have that your what? Your in y, that's logarithm natural log of y equal to what? Log of what? X raised to the power of x squared. From the law of logarithm, I can actually bring this to this side, so I can rewrite this for easy solution to have x squared, that is this log of what? X from the law of logarithm. I apply this. So now, if you look at this function now, we are going to differentiate because we asked to differentiate this function. So the next thing is to differentiate. Check both sides. And if you differentiate both sides, if you differentiate this, you have what? You have that if you differentiate in y, you have what? 1 over y. But because of the type of variable it is, you rewrite what? The y, the x. Remember I taught you in the previous video about what? About dependent and independent variables. So I want to differentiate this, but if you notice that this is a product rule, and in my previous video I taught you how to differentiate the product rule. So let's bring this up. Let's bring this up to like x squared in what? In x. Please, you are going to follow me because I'm standing left. I'm not comfortable, but you have to watch me very well. I'm just bringing this out so we can differentiate this. And I said this is what? Product rule. And what does the product rule say? It said that if I have my u, I can have my dv dx, added with what? My v du dx. This is the formula for product rule I taught you in my previous video. So the first thing you have to do from this function, my u is what? My u is x squared, so that my du will be what? My du dx. Apply the times and take formula. I'm going to times this with the coefficient I have to x. Subtract 1 and I'll be left with 1. And my v is what? My v is in x. From here, this is my u, this is my v. So that my dv dx is what? 1 over x. Anytime you are differentiating a log function, you have 1 over the function. So because we have the parameter, we are going to substitute it into the general formula. So that what is my u? X squared. And what is my dv? My dv is 1 over x. So I open a bracket to write my 1 over x plus, what is my v? My v is what? In x. Please follow this very well. And what is my du dx? My du dx is what? 2x. So I open a bracket and write my 2x. So implying that the differential coefficient of this product rule is going to give me this. So let me open the bracket very well so that I'll have, if this cancels this is x. I'll be left with what? X. And if I multiply this out, I'll have plus what? 2x in x. So that is telling me that if I differentiate this function, this is what I'm going to have, and I'm going to substitute this inside this solution now, because we are asked to differentiate this function. I differentiate this to have this, so I'm differentiating this to have this, so that will be what? X squared plus what? 2x in x. But this is not the final answer, because I was asked to find this, dy dx. So I'm going to make this the subject of the formula by doing what? Multiplying the left and the right hand side with what? Y, so that I can take away this. So we are going to move this to this side. From here, we have that 1 over y into what? Dy dx equal to what? Equal to x. Please, there is no square. Equal to x squared. This has cancelled this. Equal to what? X plus what? 2x in x. So if I multiply both sides by y, this will go, so that I will have what? My dy dx equal to what? X plus what? 2x in x into what? Y. Because we're multiplying both sides by y. This should have been the final answer, but you can recall that you say let your y be this. Let your y be this. Let your y be this. So we are going to substitute the value of y to have our final answer. So recall that your y is what? X raised to the power of what? X squared. Please, this is my x. Don't mind my handwriting. Recall that your y was this, so we are going to substitute this inside this equation, so that we have that my dy dx is what? Is x plus what? 2x in x into what? Y. X raised to the power of x squared. And this is your final solution. This is your final solution. So anytime you are asked to differentiate this particular function like this, the first thing you have to do is to say, let your y equals to this. Take the natural logarithm of both sides and you differentiate the function. Where it needs be to apply product rule or quotient rule, you apply it and you arrive to your answer. Okay, this is the first question. So, and subscribe to the channel Math of Face with Enabling. Just searching on your YouTube, you'll see. Subscribe to the channel for more videos. We are going to take the second question. The second question is very, very funny, believe you me, but you're going to do it. Thank you.